Hello everyone, so today we are going to learn about application of differentiation. We will learn about what is differentiation, when do we apply differentiation, and what are other applications of differentiation. So this is a few terms that we should know before we learn this topic. First is derivative. In mathematics, derivative means the instantaneous rate of change of a function with respect to one of its variables. While second, we have differentiation. Differentiation means process of finding the derivative or rate of change of a function. There are three basic derivatives. First, for algebraic function in which is any real number. Second, for trigonometric function, and third, for exponential function. So today we will learn about related rates. What is related rates? Related rates involve two or more variables that change at the same time, possibly at different times. Once we know how the variables are related and how fast one of them is changing, then we can figure out how fast the other one changing too. This will require us to write the equation relating the two variables and taking the derivative of the equation. So, let's try to solve a few problems. Other basic rule, which is chain rule, provide a way to differentiate a composite function. Hope this will help you while trying to solve the problem later. Here are examples of rate of change that we might come across in this video.
Problem statement 1. Air is being pumped into a spherical balloon so that its volume increases at a rate of 100 cm³ over second. How fast is the radius of the balloon increasing when the diameter is 50 cm? In this question, we have to find dr over dt, which is the change of radius over the change of time.
From the question stated, we can get the information about the balloon sphere, whereas dv over dt, the change in the volume over time, is equal to 100 cm³ over second, and the diameter of the sphere is 50 cm, while the radius is 25 cm, since the radius is the half of the diameter. To see how this value relates, we need an equation that relates V and R, which equal to the equation for the volume of sphere, like 4 over 3 pi r cubed. We need to find the radius increasing when the diameter is 50 cm, where we can compute in dr over dt. By using the chain rule, we can come up with an equation dr over dt equal to dv over dt multiplied by dr over dv. So we will find out dr over dv after this. To find dr over dv, we need to differentiate dv over dr, that equal to 4 pi r squared. And we will get dr over dv equal to 1 over 4 pi r squared. So then you can plug in all the information in this equation, which is dr over dt equal to 100 multiplied by 1 over 4 pi multiplied by 25 squared. Then your answer will get 0.013 centimeter over second.
Problem statement 2. A ladder 10 feet long rests against a vertical wall. If the bottom of the ladder slides away from the wall at a rate of 1 foot over second, how fast is the top of the ladder sliding down the wall when the bottom of the ladder is 6 feet from the wall? In this question, we have to find the change of axis y over the change of time.
So for question number 2, there's the diagram shown here that still a ladder with a constant length of 10, and there is the value that are the variable x and y as they both change over time. That shown a right triangle with a non-hypotenuse. The variables can be released by Pythagorean theorem. That will be x squared plus y squared equal to 100 or 10 squared. So let's differentiate with respect to the time. The derivative of x with respect to time will be 2x times dx over dt plus 2y dy over dt equal to 0. On the right derivative of any constant will be 0. Then, to solve this, we will take the term with the all x to the right side, and then we will divide it by 2y, that will equal to dy over dt equal to negative x over y times dx over dt. To solve the equation, dy over dt equal to negative x over y times dx over dt, dy over dt equal to negative x will be replaced by 6 based on this diagram in 8, and y will be replaced by 8. By Pythagorean theorem, we can solve y at that instant. So dx over dt is 1. So we will come up with the answer negative 0.75 feet over second.
Problem statement 3. The diagram given is an open-top container full of water. The container is made up of a hemispherical bowl of radius r attached to the bottom of a cylinder with radius r and height h. If the surface area of the container is 288 pi cm squared, show that its volume is V equal to 144 pi r minus 1 over 3 pi r cubed. Hence, determine r so that the volume is a maximum.
So for the last question, we need to find, firstly we need to find the height of the cylinder, and second we need to substitute h into the equation to prove V, and so we need to find the value of r. So the first thing first, you need to remember this is an open lid container, and here I have provided the equation for the hemisphere and cylinder. For the area of the surface, okay, first 4 pi r squared divided by 2 plus 2 pi r h equal to 288 pi centimeter squared. So 2 pi r squared plus 2 pi r h equal to 288 pi. So it will bring this to the right side. So it will be 2 pi r h equal to 288 pi minus 2 pi r squared. So we will left h here. So it will be h equal to 288 pi minus 2 pi r squared divided by 2 pi r. H will be equal to 144 divided by r minus 1r. So for the second, we need to find value. We need to prove v. Okay, so the equation of the volume for this container, it will be 4 over 3 pi r cubed divided by 2 plus pi r squared h equal to 2 over 3 pi r cubed plus pi r squared. So the h here will replace with h that we get here. So we put it into here, and it will be pi r squared multiplied by 144 over r minus 1r. So it will be 2 over 3 pi r cubed plus 144 pi r minus 1 pi r cubed. Next, equal to 144 pi r minus 1 over 3 pi r cubed. So the equation is proved. So lastly, we need to find the value of r. So we will differentiate the volume here. So dv over dr equal to 144 pi minus pi r squared. So this will be 0 here, equal to 144 pi minus pi r squared. So with variable r will be bring to the left side. It will be pi r squared equal to 144 pi. We can cancel the pi for the both side, and it will r squared equal to 144. So we can put here, square it here for the left side and for the right side. It will be r equal to 12. Final answer, r is equal to 12 centimeters.
So from this video, we can conclude that the main thing to solve the problem is draw the diagram if possible. The problem stated for each question different for each. We have to know the objective to achieve by knowing which variable need to differentiate and solve. Understanding the question is really important to avoid silly mistakes while solving the problems.